using only values less than -1, right? But I had told you guys to use -1 also because we wanted to make sure if the two parts would be connected or not. Yeah, so you started at -1, -2, -3, however far you want to go, right, on the negative side. And then
really, it only goes to -3 because after that
you won't be able to plot it, right? Yeah, exactly. So what did we get for our y values then for this guy?
-1 and 1. -2 and 4.
4.
-3 and 9.
Good. And yeah, that guy would be beyond, right? Yeah, you don't have to. Okay.
The other one would just be.
And starting back at -1, right? Because this guy's telling you it's including -1. So you start at -1 and then you go
1
to the right as far as you want to go, right? Positive side. So what do we get for y value for the -x part?
1.
Yeah, negative will become positive. Positive will become negative. Yeah, so these guys will be -1, -2, -3. So the first thing is make sure you have the right values on your table. Because if these values are incorrect, then your graph's going to be incorrect. So again, for the x squared part, they're asking us to use x values which are less than -1. But because we want to know how the two graphs are behaving, we are actually still going to use -1 for our calculation, and you end up getting these values for your x and y for the x squared part. Now, for the -x portion, they are saying x greater than or equal to -1, right? Which means we again use that -1 here, and then anything greater. So you can do 0, 1, 2, 3, whatever numbers you want to use. So in this case, if I put x as -1, the two negatives become positive. But when I put x as +1, that makes it a negative. So positives will become negative, negatives will become positive. And here's the other thing. These 2 points are exactly the same. So that tells us the four parts or 2 pieces of our graph will be touching each other, right? So when you graph this, you've got -1, +1, -2, 4, and -3, 9. And then we've got same thing, -1, 1, 0 was at 0, +1, -1, +2, -2, +3, -3. So this part here is the x squared. So this will be that parabola shape right here. And then from here, we start going down to basically a straight line, right? So that's kind of what that graph should look like. So right at this point here, at -1, 1, is where that parabola will now change and become the straight line. So make sure your graph is looking that way. Did you already have your graph done? Okay, very good. Now, what is your domain and range for this function?
-infinity to infinity.
For,
Domain.
okay.
And -infinity to infinity for range as well.
Yeah, because you are covering all of your x and y values. So this arm, of course, is going to the left as it's going up. So he's covering the -x values. This arm, of course, is going to the right. So that's covering the +x values. And then, of course, you can see this is going up to +y. This side is going down to -y. So you have all real numbers for your domain and range here. So yeah, very good. Negative to positive infinity. Negative, positive infinity. Okay. Did anybody have question on this one?
I remember we were just talking about this, but at the end of last class, I asked, when we get our domain and range, are we basing it just off of one or both combined? Because if you just base it off of one, then those numbers change.
Are you saying like one piece, like just x squared or negative x?
So we got 2 charts that we built in order to have that correct.
Yes, yes, because you know the idea is even though they are 2 individual charts, they are both part of the same function, right? Because technically we only have one function. So when you're actually talking about domain and range, you are combining both of them together to figure out. So in this case, you wouldn't just look at one side or the other, because when you look at the graph, it is a continuous graph, right? So these two pieces are connected together. And even if they were not, let's say there was a little gap in here, this would still be one function. So you still have to treat that as one entire unit. So when you're doing your domain and range, yeah, you want to look at all parts. So even if this was one of those examples that has 3 parts to it, you would still need to look at all 3 of them together when you're doing your domain and range. Yeah, so that's a good question. Very good. Anybody else? Any other question on this guy? All right, so those were our piecewise functions. The last one that I want to talk about in terms of piecewise is, I had kind of talked about the shipping charges example where based on weight or distance, your shipping charges would be different. So leading into that, we have our greatest integer function here. So basically the idea here is, and we're just going with the weight aspect. If you have a package that weighs anywhere from 0 to 1 pound, and that's including 1 pound, right? Because we're not including 0 here, but you've got a bracket on the 1, which means we're including the 1. So if you're right at the 1 pound mark, let's say you're charging $3. And of course, these are not real numbers. This is just me coming up with numbers. So let's say they're charging $3 to ship this package. But now if you are at like 1 pound and so many ounces, which means now you've gone to the next level. So you would be going from 1 pound up to 2 pound range. And then in that case, your value went up by $1, right? So instead of paying $3, you're now going to pay $4. So greatest integer function kind of works in that same sense, is that for each 1 unit change, your y values are going to be something different. So we kind of use this little symbol here, which actually looks like double brackets. I'm not sure how obvious that is, but it should look kind of like this, like double brackets. So that way we know we're looking at the greatest integer function, or sometimes you will actually just see them writing it as integer of x, int x. So in this case, the idea here is the way we define this greatest integer is as the largest integer that is less than or equal to your x value. So whatever you have in here, when you're trying to evaluate it, you're looking for the largest integer that would be less than or equal to that x. So let's say you've got 5.01 here. So what is the largest integer which would be less than or equal to this number, right? And that's where that 5 is coming from, because 5 is the largest integer, because it can be equal to, since this is not an integer. So the largest integer which would be less than 5.01 is 5. And if it helps, you can always think of these as numbers on a number line. So let's say I have 5.01 somewhere over here. And that's going to be between 2 integers, 5 and 6, right? So which is the largest integer which would be less than 5.01? It's going to be 5, right? Because 6 is too far away from it. So you can kind of think of this, if I place this on the number line, where would these numbers be? So same thing with 3.2. 3.2 is going to be between 3 and 4, right? So the largest integer less than would be 3. If it's an integer itself, that's actually where that equal to part kicks in. So if it's 7, it will be 7. If it's -2, it will be -2. But if it's anything which is a decimal, then you have to see which integer is less than that number, okay? So how do we translate that into trying to graph this? Now this will be the interesting part we'll have to look at. Okay, so I'm actually going to, let me see if let me open this guy. Okay. So this is number 10. Okay. And they are also asking us to find what the domain and range for this function would be. They want us to find some values and try and graph this, and your graph is here on the next page. So let's see how we can go about doing this. So for the greatest integer function, we actually have to think about not just in terms of single values, but in terms of an interval. So if you look at the first part here, normally we would have probably gone with like 1, 2, 3, -1, -2, -3, right? As we did in our previous examples, but we're not going to do that here. So what we're actually going to do is think about numbers going from 0 to 1. I'll tell you why. So if I have numbers right at 0, 0.5, 0.99, and let's say 1. Okay, using this idea of the, and you can do that as 0, 0, 0. If you think about in terms of the greatest integer function, we define it as the largest integer that is less than or equal to x, right? That's what we had in that little statement here, right here. No, 0 is a real number. It's an integer. It's just not a whole number, right? But yeah, you can think of 0 as an integer. So 0 would be 0, right? When we try to use this definition of the greatest integer function. So this guy will be 0 using our greatest integer function. Now for 0.5, using that greatest integer function definition again, where will this guy be going?
0.
It would be going to 0. 0.99
0.
would also be going to 0. I was like, I know this. I got this. So what's going to happen at 1 then? Yeah, so at 1, we're no longer at 0, right? Because now we're going up to the next level. So the way actually you define your x values here is you are including 0, but you're not including 1. So what you had in your little handout for the shipping example, we were not including 0 and we were including 1, but for the greatest integer function, those brackets change. So you have a bracket on 0, but a parentheses on 1. And all the values between 0 and 1, not including 1, you can see we did that right here, are heading to 0. So this value here for all the numbers between 0 and 1 are all going to be going towards 0.
But since 1 can be there, that's not accepted. 1 is one of the answers, right?
But it's not including 1.
But it's not including 1, right? Because at 1, 1 is an integer itself, right? So when you use the definition of the greatest integer function, then this guy is going to 1, not 0 anymore, right? So he is not part of this group anymore because 1 is now actually starting its own group, which will go from 1 to 2, but again, I cannot include 2 in that. So anything again between, it is, because that guy will be equal to itself, right? 0 would be equal to 0. Because you do have less than or equal to. So 0 would be equal to 0. But then 0.5 would be in the less than category, right? And that's why he's going to 0. 0.99, even though it's closer to 1, but the integer less than is 0, right? So that's why 0.99 is also going to 0. But the moment I get to 1, now 1 is an integer, which means 1 will equal itself. It won't equal 0 anymore. So that's why we are not including 1 in this little interval. So 1 will start its own group, and he will go from 1 to 2. So all the values in 1 to 2 interval will be going to which integer?
So it's not really based on since it can only go 0 to 1 and 1 to 2, it can only go so far on itself anyway. So it's locked by a principle, not necessarily.
Yeah, and that's because of the way we define the greatest integer. Yeah. So if you follow this pattern, this guy is going to 1. Now 2 is starting its own group. He goes up to 3. Where will all the values between 2 and 2 be going? 2, yeah. All right, now let's mimic this on the negative side. So we were starting at 0 here. So now we will go from -1 to 0. So one step back. So think about it this way, -1 negative 1 point, I don't know, 73. Where would these numbers be heading? They would be heading to negative 1. Very good. And then your next category would be going from negative 2 to negative 1. Negative 2. So what's the key here? You're always going to that lower number, aren't you? Whatever is that lower end of your interval is where we put the bracket on. That's exactly where all your y values will be going. Okay, before I actually get to the graphing, anybody who's still a little unsure at this point?
Makes sense.
Make sense? Okay. Okay, I'm actually going to do a rough graph here since we're on this page, but then I'll go and show you on the other one. So let's just do a quick x and y axes here.
So we plot that x value,
Uh-huh.
that's including 0, but not including 1, you just plot it at 0? Or no, you plot it.
You're almost on the right track.
Would it be like,
Did you say positive 0?
would it be like a line
I did.
across the,
He's making fun of you.
would it be like a line, like, would it be a line connecting the 2 points, and then it would go up, and then a line across the 2
Look
points?
at that. Very nice. It will exactly be like that.
So it'd be like
Yeah.
steps.
It will be like that.
Oh.
Look at that. Even though you made fun of him, he was on the right track.
I got it. Say it again.
Okay, but now here's the thing. We are including the left-hand number, but we're not including the right-hand number. So how do you show that?
A closed ball and open that.
Open circle. Yeah, remember we talked about that when we were doing
Oh,
interval?
that's gonna be like six.
So, okay, taking it step by step. So we're doing this part first. So I'm going from 0 to 1, which is this little interval here. And we are saying all the y values are going to be 0 at this point, which means going from 0 to 1, all the numbers between 0 to 1 are going to be at 0. So that's going to be there. I am including 0. Oh, come on. Close circle on 0, but I have parentheses on 1, right? Which means I'm actually going to have an open circle at 1. Okay? Then when we are between 1 and 2, which is this side here, between 1 and 2, our y values are actually going to 1, right? So between 1 and 2, you're actually going to be at 1, which means we'll have our step right here. So that's going to be from 1 to 2, we are at 1, which means again, oh, why are you doing this? Come on, buddy. Close circle at 1, 1, open circle at 2, 1, and that's your little step. So this pattern will actually keep continuing as we change our little interval. So now if you go from 2 to 3, which is this side right here, from 2 to 3, we are at 2. So again, close circle at 2, open circle at 3.
So how do you connect these? Just straight down?
No, they won't connect. They will stay like these. They will be just
you don't.
little steps, yeah.
Okay.
And that's the interesting part of this greatest integer function. I mean, this is honestly what you would think of piecewise functions, because every piece is different, right? Because it's being defined by that little x interval that you have.
Okay.
But it
so
makes
no-
one full function, right? So
Right.
this pattern will continue even though I don't have all my numbers there. The idea is this keeps continuing as you keep moving forward. Now the same thing's going to happen on the left-hand side when we go from -1 to 0. So that's this interval, but we're actually at -1, right? So you're actually going to be right here at -1. So again, left-hand side has the closed circle, right-hand side has the open circle. And then we go down to -2, -1, close, and then again, open circle. Go down, this guy would be -3 to -2. So that guy would be going down. And of course, this pattern keeps following for the entire stretch of your graph. So if you do that here, you would literally be having closed circle, open circle, which is not going to come out looking very pretty. But same thing all the way through, closed circle, open circle. Oh, that's just dot, 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 dot. It's not a line. This is just to show you that it continues. Ah. Yeah, I mean, I would do a couple of these. That should be an open circle, and then
So
you
when
can
we
just do
graph it,
like that.
Just to show that we understand what it goes for every.
Yeah, I mean, you don't have to do for the
entire.
entire graph. So I would do a couple and then just do dot, dot to show it's going to keep going.
Okay.
And that's the thing I want you to understand. It's not going to stay just within these numbers, right? It's going to do this for the entire negative to positive infinity stretch of your graph. Okay, you cannot answer this question. What will be the domain of this function? Okay, and why is that?
Because it's the one that's going on the bracket, and so the non-negative.
Yeah, because even though we are not including a given number at the upper limit, we do end up including it at the lower limit, right? So I am using 0 to 1. Well, everything close enough to 1, but then I start back at 1 here. You can see 0 to 1, not including 1, but then I'm including 1 here. Not including 2, but I'm including 2 here. If you look at the graph itself, think about, collapsing this graph. So everywhere that you have an open circle, that closed circle will come and lock in. Will it not? If I just collapse these two steps. So this circle, think about it, what is that? Oh, the hook and the, oh, it's a carpentry term. Never mind, I will have to ask Scott about it. But it's the idea where, they claw into each other. So that's kind of what's going to happen if you think this guy has a little peg that's going to lock in and lock into that one. This guy, same thing. So if I collapse my entire graph, it will actually become just a straight line because all of these open circles will have a closed circle that's going to overlap on top of it. So that's why you are actually using every single x value on the x-axis. So yes, you are going from negative infinity to positive infinity on your domain.
You're also using a new line.
What do you mean? In line in terms of range? No. Because what's happening with range? There is a space. Very good. Because the idea of collapsing is just to understand how the x-axis works. We're obviously not collapsing the graph. It will stay as it is. So these gaps that you have between these numbers, you have no graph between those graphs. Your number, where is your y value at? Every integer, yeah, very good. So you are actually only looking at integers as far as the y value goes because there is nothing in between here where my graph is existing. So I have -3, I have -2, -1, but nothing in between. So in this case, your range is actually going to be the set of integers. Some textbooks use that symbol for integers. It's like an I with 2 bars instead of just 1. Or you can just say set of integers. So it's a very interesting function, something we have not seen so far, right?
Yeah, I don't remember ever doing that. Ever.
Yeah.
That's cool.
And a lot of times you will see these kind of examples being used in logistics. So, like our shipping example, that kind of thing where each weight bracket forms a different price range. Be interested to see what Amazon does with its shipping charges.
So on the chapter 2 exam, are we gonna see mostly this stuff, or are we gonna bring in some of the chapter 1 stuff too?
I mean, it may be interconnected, but nothing specifically from chapter 1. Yeah, I mean, chapter 2 will be dedicated chapter 2. Yeah.
So if we see chapter 1, we'll probably see it as well.
Yeah, I mean, you will see some of those, Yeah, equation solving and stuff like that, the inequalities and stuff we had done. Quadratic formula will make a reappearance, completing the square. Yeah, yeah. Alrighty. And this is not a question, but how brave are you feeling about doing the next one? It's the exact same thing. Look at that, very good. Same exact function, but now they're giving you x plus 1 inside of that greatest integer symbol. So use the example we did for 10 and see how that plus 1 changes your graph and your values. So let me go ahead, write this down.
Wouldn't it just skip an integer?
It would go up 1, yeah. So you would still keep your x values the same, right? Those intervals would still be the same, but now your y values will change.
But the y value should be one more than
Okay, so what will it become?
that would be 1, 2,
And then do you want us to do it all?
Yeah, so that way you kind of have an idea on both sides. Yeah. Bless you. Okay, so think about it this way. If you're struggling with what your y value should be, use 0.5 because that's right in that middle of that first interval, right? So if you're using 0.5 for your x value, that will become 0.5 plus 1, which will actually become 1.5. So what is the integer which would be less than or equal to 1.5? 1, yeah, so these guys will actually end up going one level up, right? One step up if you think about it as steps. So 1, this guy originally was 0, it's now become 1, which means this guy will become 2, 3. But then what's happening at the -1, 0 interval? No, you will not because there will be no skips, right? So because this guy did not start at 0 and this is the interval right before that, he's actually going to be at 0, but again, use a number to verify. So if I instead, between -1 and 0, what number can I use?
Oh, no.
Negative. Negative, yeah. So just a matter of if I make this guy into a negative 0.5, so what is negative 0.5 plus 1?
Negative 1.5.
No,
Oh, what?
you're subtracting half from a 1. Nope.
Negative 0.5.
Nope, positive 0.5, yeah? Because you're taking 1 and subtracting a half from it, right? So this will actually become positive 0.5, and where is positive 0.5 heading? Will be going to 0, yeah, so this guy will be 0, which means he is -1, he is -2. Because remember, all these values have to go up by 1 compared to what you had last time with example 10. So where will my first step be then? For 0, 1.
Well, it would be 0 on the x and 1 on the y, close that. open
Yeah.
At 1.
Yeah, so let me show you with our first example. This step was right here on the x-axis, right? But because of that +1, this step has actually gone up 1. So instead of drawing it here, you're actually going to be drawing it here. So each step from this example is going up 1 step. So this guy will now be starting at 1, 2, and going to 2, 2. What will this be? 2, 3. And that pattern will again continue all the way through. Then for the negative side, between -1 and 0, you're at 0, which is actually going to be here. Okay? So again, same thing, closed circle on the left, open circle on the right. And again, this pattern will continue. So with comparison to example 10, how has our domain and range changed for example 11? It hasn't changed? Yeah, because you're still covering all the x values, right, on your x-axis. You're still going to be using all of them. And even though our range went up by 1, we are still going to be actually using all of those integer values on the y-axis. We're just 1 step up from where we were before. So yeah, your domain and range have not changed. Very good. All righty. Did anyone have questions about 11?
So if you had, instead of a +1, if you had a -1, it would just drop to a -1? and
Yeah,
you'd
so
do the same
instead of
thing?
starting at 0, 0, you would be starting down.
What would happen if we had a number in front of X?
In front of the x, then you would be possibly shifting, I would imagine. So let's say if you had 2x plus 1, right?
You shift.
So because remember the 2x brings in the, I guess we haven't really talked transformation stuff with you guys yet, but basically you're stretching your function a little. So think about it. If this guy was, sorry? Yeah, I think so, something like that. Because if you had 2x plus 1, how would that change? Yeah. That's a good question,
Since the
yeah.
bracket is already in place on the X, then you just
So-
the range can only go and yeah, block.
Yeah, so that's the thing. What would,
Force it to stay within size. Can't get any longer than those 2 points because it doesn't allow it based on.
because our range would still be staying between, I mean, the interval would still be between 0 and 1. Yeah. But then where would your steps be at? On the y-axis, where would you be at? The x intervals will stay the same, yeah, because that's just how we define these functions. So let's say again we put 0.5 for our x in 2x plus 1. What do you get? If you did 2 times 0.5 plus 1, where would you see? 2? Because 2 times 0.5 would be 1, right? 1 plus 1 would be 2. So what does that tell you then? If I used, instead of 0.5, let's say I used 1.5, where would I be then? So this guy would be going to 2. But if I used 1.5 here, where would I be?
When it goes up, it goes 2 each time, like however many it would. It wouldn't sign on diagonals.
The gap would increase is what I'm
like
thinking.
going up when you go from one end to the other one.
Yeah,
It should get increased each time.
it should. That's what I'm thinking, yeah.
However, the X could still be any negative.
I mean, you're still doing one step at a time, but what's happening here? So let's say if we graph or try to graph this guy between 0 and 1, you're actually going to be at 2, which will be here. But then between 1 and 2, you're actually going to be at 4, which means you would actually be here. So what's happening with that factor of 2 is instead of these being 1 integer apart, you're now 2 integers apart. So that's the stretch that'll happen. But I mean, you will still keep that step process, right? I mean, it's still going to be in those steps increment. Your width will still be 1 unit, right? 0 to 1, 1 to 2, 1, 3 to 4, whatever. But now this gap has increased between your functions.
The x would still be the same. Now our y, since that's slope, since those can now be decimals and not just whole numbers, would that change everything? No, because it would still be the same.
Yeah, it's just going to make it a bit steeper because now you're climbing, instead of every step, you're climbing every other step. So domain will still stay the same, but the range will now not be the set of integers. So this one I would probably use set builder notation to write this one down because I don't think you can use. Yeah, so this is where we would actually have to define it as, so this actually would look like, we're talking in terms of y value. So you can say y is, oh, hard to see. Let me do, okay. How do I want to say this? Y is an even integer. So you would have to almost define it like that. And we call it set builder because we're saying, okay, y is my variable, but then what does y stand for? Because I don't know if you can really say set of even integers. I don't know. That is a trick question. Yeah. No.
Okay, let's
Hey, if you guys can even do just the greatest integer x or greatest integer x plus 1, I think that's still, something different that you have not seen before. So we don't want to make it too complicated because, again, the idea is to feel comfortable with the piecewise functions and part of that being the greatest integer function, but, not go too in depth because you're not going to be seeing that in this class anymore. Now, if you were going into a class where they needed you to have more knowledge about this, they'll probably do it there. But for our class, we're not going beyond what you see in example 11. Okay? All right, very good. Good question. Anything else? Okay. All righty, guys. Let's see if we can try and at least get this guy completed for today. That's done. Now talking about increasing, decreasing, and constant functions. So, of course, with a straight line, when you're talking about an increasing function, you're basically talking about a function that would have a positive slope, right? A line going up. If you're talking about a constant line, you're basically saying your value is not changing, right? It's staying constant, which means you're actually just going horizontally along that line. And then if you're talking decreasing, then of course that means you have a line that has a slope which is negative, right? This line is going down. But when you're talking about increasing, decreasing, and constant functions, other than a straight line, the idea is if you're looking at the graph of the function, if you start at the left end of the function and go along that function, is it making you go up? Because if your function is going up, it's increasing. If, of course, you're just going in a horizontal line, your function is constant. If it's making your value go down, then your function is decreasing. The other way to think about it, going from left to right, are your y values getting larger? If your y values are getting larger, your function is increasing. Going from left to right, if your y value stays the same, that's constant, right? And going from left to right, if your y value starts decreasing, so let's say you started with positive but are now going towards negative values, your y value is decreasing, that would be a decreasing function. So that's kind of what this little definition here is talking about, is in terms of if you look at two different values where f of a is the left side of the value and f of b is on the right side of your graph, then is it increasing, decreasing, or staying constant? So we have actually used just simple examples here with straight lines to kind of get the idea of increasing, decreasing, and constant to help us out. So you can actually do your little table right underneath that. Pick 2 or 3 points for X and go ahead and graph your lines.
FX should be Y.
Yeah, so it's just because we're using function notation, so instead of Y, they're just using f of x.
Okay.
But that's just staying with your function notation, yeah. So if it helps, you can think of that guy being as your Y. And again, stick with simple numbers. You don't have to do anything too large. You can use, if it's easy to graph, -1, 0, and 1, or you can do -2, 0, and 2. Christian? That looks right. Yeah, very good. And you actually said you had a question on this one. So you started at -2. Yeah, so this one, of course, the idea was you want more to connect. And that's what you did in the but that is where the graph changes. And then this guy looks good because that's positive. Which is that's negative. So no, you can use these numbers for your X, but Y for you.
I'm not sure how.
Okay, this will be interesting to try and graph, but this guy is 3x, so that will be -3, 0, +3, right, for your y values for the first one? Okay, so you've got 0, 0, -1 is at -3, +1 is at +3. Something like that. So as we go from left to right on this graph, what is happening to our y values? Increasing, yeah. So this is an increasing function. Okay. If we use those same x values for the second one, what will we get for our y values here? -3 times -1. Yeah, so your signs are going to reverse, right? Whoa. Okay. Nope, don't need you. Where did he come from? I have no idea. No, I don't want this one either. Oh Lordy, I'm losing it, people. Alrighty, so what will this graph look like? Decreasing, yeah. So -1, +3, +1, -3. Okay. Y values are getting smaller as you go from left to right. That's decreasing. And what's happening on this last one?
It's the same graph, it's just decreasing. Well, it's like it's opposite. So it's
Negative slope, right?
yeah. So the 1, -3 is 1 of your points. 2, -6.
Okay, why are you? It's not writing anymore. That is a constant function, yeah. So what will we have then? This guy just died on me. So if I use the same x values, what will my y values be? For all of them? Yeah, because it's telling us f of x equals 3, which means your y equals 3. So it doesn't matter what your x value is, your y is always going to be at 3. So, and I don't know if this guy's gonna let me graph, it will not. So you should be at basically a horizontal line going this way. And that will be your constant function, yeah. Now, you know, every now and then, I did this kind of as 3 different graphs, but you can actually have that same behavior happening within the same graph. So you could have a graph that could kind of start out this way, you know, go down. I mean, no, honestly, within the same function, you can have different things happening. So at this point, let's say this is going to be, I don't know, -3. Let's say this point here is going to be -1. It can be. You will actually see examples like that in homework. So let's say this guy is going in this direction, this guy is going in this direction. So they can actually ask you on what interval is your function increasing, decreasing, or staying constant. So now think in terms of anytime they say in what interval, you are talking about the x-axis, okay? Anytime they want interval notation, it's always the x-axis. So what's happening here? What is this graph doing on this left-hand side part? Is it increasing, decreasing, or staying constant? It is staying constant because it's a horizontal line. So it is constant, and what would you call that interval? Interval is 2 numbers, right? From here to here. Yeah, because that guy's going left, right? Which means he's going towards negative, the extreme left. Yeah, so this little portion right here on the left-hand side. So this arm would be going to the left, which means it's going to negative infinity. So you are constant on negative infinity to negative. Yeah, I think your textbook does that. So normally when we talk about intervals for increasing, decreasing, or constant, we don't normally include the endpoints. But thank you, Iram. Your textbook actually does want you to include the endpoints. Infinity still you wouldn't put brackets on, but for the numbers, they will want you to put brackets. The way I learned it was because we're only talking about intervals from where this behavior is happening, you don't normally include your endpoint. So that would just be parentheses. But because I know my math lab will count it wrong, you have to put brackets. So, and that's because the author of this textbook decided they wanted to put brackets on them. And on the test, it'll be brackets, because that's what you guys will have practiced with. I mean, for intervals, on this, if you put parentheses, I won't count it wrong. But because, you know, we do other intervals where you have to put brackets or parentheses, I think it's just good practice. So just follow that. Okay. Now, what's happening between -3 and -1? It's decreasing. Yeah, very good. Yeah, because that's how your textbook wants it. So we'll just keep that. My mathematical brain hates doing that, but I don't want you guys to get answers wrong because I have a view, but your textbook does not. But you know, if you take a calculus class, because that's where I learned this, and they always use parentheses. So it's what I'm used to. All right, going from -1 to +1, what's happening? Increasing, very good. One, two, three. Decreasing, very good. Ah, there I go again. I do, because that was from our graph. One note has been acting a little weird today, so it's not letting me write everything I want to write. And what's the last interval and what's happening on that?
Constant.
It is constant. Very good. So you will actually see, instead of individual graphs like the example has, your homework kind of has in the same function, these kind of things happen. Okay? Question?
I kind of have a question that's kind of similar, but it was on the homework that I was trying to do. So it kind of had a graph similar to this, but it wanted to know like what is the increasing range of like the function or something like that it was asking. And I couldn't figure out like how it was coming up.
And this was from 2.2?
Actually, it might have been 2.3.
2.2?
It might have
We can take a look at it after class. Yeah, we'll pull it up and see what exactly the question was. Okay. All righty. So that is your increasing, decreasing, and constant function, which I believe is the end of 2.2. All righty. I think I gave you guys 2.3 handout last time. Did you not have that? Okay, I'll get it to you. Okay.